Hey everybody, my name is Calvin and welcome back to episode 7 of my Learn Python series. Today, we'll be covering the math you need as a beginner Python programmer. I'm talking about the everyday operations you use in real programs, adding, subtracting, multiplying, dividing, keeping track of totals, and understanding what Python is doing when it produces a result. This is important because most programs do something with numbers. Whether you're working with money, time, scores, counts, measurements, or anything else, you need to be comfortable with basic numeric operations and the numeric types that Python uses. You also need to understand what kind of number you have, because an integer data type behaves differently from a decimal number, and division behaves differently depending on what operation you use. Before we jump into the code, there's something I'd love to share with you guys. Have you ever wondered how the biggest companies in the world organize, sort, and analyze their data? It's from the work of data engineers. Data engineering is the backbone of modern analytics, business intelligence, and machine learning. Data engineers in the US earn around an average of $130,000 per year, with some even making over $200,000 annually. Hi, my name is Calvin Lin, and I wrote this book because this is something that I wish I had when I first started out. From databases, data warehouses, and real-time data streams, this book will give you a great foundation to launchpad your data engineering career. This is Modern Data, from Ingestion to Production. Available on Amazon, Apple Books, and Barnes & Nobles, so get your copy today. My book, Modern Data, from Ingestion to Production, is available on Apple Books, Amazon, and Barnes & Nobles, so please check it out. Hopefully you guys can learn something from it, and I'd love to hear any kind of feedback you guys might have. Let's jump into the code. We'll create our Lesson 7 folder, like before, and we'll create our first exercise file. Before we do any math, we need to understand the two main numeric types that we'll be using constantly, the int and the float. We've gone over these before, but we'll dive into it deeper here. An int is an integer. It represents whole numbers like 0, 5, -10, 42. A float is a floating point number. It represents numbers with decimals like 3.14, 19.99, or -0.5. Again, we don't manually declare types in Python. Python will decide the type based on the values you assign. Again, that's called dynamic typing, and it's convenient, but it also means you need to know what type you're working with when you do math, because the output type can change depending on the operation. Say we initialized an integer, a, and we set it to 10. Now we had a float, and we set it to 3.0. The way we initialize an integer is just a whole number like this, and a float will be a decimal with a period. We can confirm this in Python by running our simple print statements, and we can check the type of A, and let's check the type of B. We can run this, and we'll see that A is 10, a class of integer, and B is 3.0 with a class of float. We also need to understand that even if two values look similar, they can still be different types. What if we wanted to initialize our integer to 3? These are pretty much the same value, but the data type is different because A remains an integer. We didn't put a .o right after the 3, whereas in B we did. And we can confirm this in Python as well. 3, class of integer, and 3.0 with a class of float. Now, what if we mixed an integer and a float in some mathematical operation? Python will usually default to giving you a float result because it needs the decimal precision to represent the answer accurately. For example, what if we had a variable result is equal to 10 plus a 10 integer plus a float 2.5. This will default to a float data type, even though the 10 right here is an integer. We can test this using our print statement from above. can confirm this. And that's what we expect. The main takeaway here is that integers are whole numbers, floats are decimals, and mixing them will usually produce a float. Let's move on to the next concept. The next concept I want to cover are the basic arithmetic operators, like addition, subtraction, multiplication, or division. They're very easy to understand because they read normally. We'll initialize a to a integer 10 and b integer 3. We can perform addition by simply using the plus sign. So a plus b will add a and b. Run this, and we get 13. Integer 13. That's simple addition. Subtraction is basically the same, but this time we'll use the subtract sign. We'll run this, and we get 7. Basic multiplication is the star symbol right here. This one you'll need to remember, it's not an X. It's the star symbol. You can run this. We get 30. And division will be the slash. The slash operator always performs true division and returns a float even if the division is even. What do I mean by that? Say we had 10 divided by 2. You would think this would give us an integer 5. But that's not how it works. This, a single 1 right here, will give us a float irregardless of whether or not these are integers. And we can confirm this by checking the type. I'm going to see 5.0 with a class of float. This is normal. We'll cover another type of division later that will help us negate this. In the next part, we'll talk about some other different types of division. In the file 7-3, we'll go over those division operations. The first is floor division, which is defined as just slash slash, 2 slashes in a row. Whereas regular division was a single slash, our floor division is 2 slashes. Again, we have 10 and 3. Now we can print a slash slash b. And what this will give us is 3, because 10 divided by 3 is 3.33. And then what the floor division here, instead of giving us a float number, 3.333, it'll drop the decimal part and simply give us the whole number. So we can run this, and we'll see that we get 3. And we can also confirm that this is a type integer. As well, class integer. Another operation I want to cover is modulo. The modulo operation gives you the remainder after division. The modulo operation in Python is represented by the percent sign. Now, what if we wanted to find the remainder of 10 divided by 3? We should expect 1, because 10 divided by 3 is 3, with a remainder of 1. Now we can check the same thing right here. This will give us an integer as well. C1 with a class of integer. We can also adjust the numbers in the case where it divides evenly. So for example, here, instead, we'll change b to 5, and we should expect for this to give us 0. We can see that this correctly gives us 2, and a modulo b gives us 0, because there is no remainder. Most times, people will use modulo to check odd versus even. This is done by using a number modulo 2. Based on simple mathematics, if the number is odd, it produces a remainder of 1, whereas if it's even, it'll produce 0. So this can be used in conditional checks to check whether or not a number is odd or even. Now we can confirm this right here. 1 and 0, what we expected. The next concept I'd like to cover is the order of operations and parentheses. Python follows standard math order of operations. Think PEMDAS. Multiplication and division happen before addition and subtraction. Parentheses override everything and force Python to evaluate the parenth part first. We can confirm this in Python with two expressions that look similar but produce different results. For example, we have a 2 plus 3 times 4. And now in the order of operations here, this should do 3 times 4, and then that gives us 12, and then we add 2, which gives us 14. Now, what if we added a parenth around the 2 plus 3? Now, this will give us a completely different answer. Now, because of the parentheses, we do the 2 plus 3 first, and then now it's 5 times 4, and we should expect 20 here. We can run this, and that's exactly what we get. It's also good to remember that parentheses are useful for readability, even when they're not strictly needed. When you're a beginner, clear code is more important than clever code. You need to make sure people are able to read your code, and you yourself are able to read your code. For example, if we had a subtotal and a tax rate, we can set total is equal to the subtotal plus parentheses subtotal times the tax rate. Technically, we don't need the parentheses there because of the order of operations, but it's definitely a lot more readable that way. The parentheses makes it obvious that the tax is calculated first and then added. The next concept I want to cover is working with negatives and absolute values. Negative numbers are very common. Think temperature changes, money spent, account balance changes, and differences between values. Say we had a variable called change is equal to negative 15, and we can denote negative values by the minus sign in front of the number. And we can print this, and we'll get the output that's very similar to a positive integer. This scenario, we would just get negative 15. Now, what would be the absolute value of change? If you remember in math class, the absolute value of the change variable of negative 15 is simply 15. And we can find that in Python by using the abs function. So let's set that to a variable called distance, have the abs function right here, and we pass in change. And then we can, did not mean to put negative 15 there. Put in change, should be the change variable. And we can print distance. And the first thing that should be printed is negative 15, and the second should be 15. We can see negative 15 and 15. We can do something a little bit more complicated. Let's say we had a variable a, and we set that to 10. B is equal to 18. Both are positive integers. Now, what if we wanted to find the difference between a and b? We can do this using the subtract operation, a minus b, and then we'll print diff. 10 minus 18 will give us negative 8, and in this scenario, that makes diff negative 8. And we can print this, and we'll get negative 8. And we can also find the absolute value of diff as well, which in this case is 8. In our next exercise, I want to cover rounding and decimals. Since we want to work with money or measurements, you don't really want to print a value with a long decimal tail. The round function rounds a number to a certain number of decimal places. Say, for example, we had a float called price, and we set that to 19.9876. We know that we would just round this at a store or something to $19.99. But if we printed it, we would get 19.9876 because it doesn't round for us. We can find the rounded number by using the round function. We pass in price, and then we also pass in how many decimal places we want. In this scenario, we want 2 decimal places because it's $19.99. You can't really have half a cent. We can make this human readable by rounding the price variable to 2 decimal places. And we print this and run it. See that it's rounded now. I also want to point out a quirk with floating point numbers. Floating point numbers can sometimes produce results that look slightly off. This is not because you're doing the math wrong, but rather it's how computers store decimals internally. For example, if we had print 0.1 plus 0.2, we get 0.3 with a bunch of zeros and 4. We know that this should just give us 0.3, but the quirk makes it so that there's the 4 at the end. Again, that's just how computers store decimals internally. The last concept I want to cover for this video is typecasting. Sometimes you need a whole number and sometimes you need decimals, and Python will not automatically do what you want. As we covered before, the int function converts to an integer, which means it drops the decimal part, and it does not round, and it cuts off the decimal. The float function converts to a float, giving you a decimal representation of the int that you just converted. Say we had a float called x, and we set that to 399. And say we wanted to typecast that to an int. In this case, you might think that we would get 4 because this is closer to 4 than it is 3, but that's not the case. The int typecast here will simply remove the .99, and then in that scenario, that gives us 3. It doesn't round for us. I'm going to execute that, and you can see that's what we get. Say we had another variable and we set it to 10. What if I wanted to make that a float? It's as simple as typecasting it to a float. And we should get something like 10.0. And as we said it would, 10.0 is printed. And that does it for episode 7. As always, we're going to be checking our Git status. We can see that we have a lesson 7 folder. We'll git add lesson 7, git commit, add episode 7. I'll push this to the repository. The goal of this video was to make you comfortable with the math that you'll use constantly in beginner Python programs. You'll learn the core numeric types, how Python decides int versus float, the basic arithmetic operators, how division behaves, how floor division and modulo work, how order of operation works, and how to use parentheses for clarity, how to round values, and how to convert between int and float when you need to. In the next episode, we'll move on to functions. Functions are going to be how we tie all the episodes that we've worked up to until this point together. So stay tuned. And as a reminder, be sure to check out my book, Modern Data, From Ingestion to Production. And thanks for watching.